Hello. In today's video, we're going to talk about how the angle of the Earth, or the Earth's tilt, affects the weather and the seasons. You might think that the hottest rays in the middle of June would be at the equator, right here on this blue stripe, but they're not. When the Earth is tilted towards the sun in the middle of June, the most direct rays are going to be at this line right here printed on the globe called the Tropic of Cancer. And if you zoom right in, it says the most northerly vertical sun rays on June 21st. It's printed right there on the globe. So what does that mean? That means instead of the most direct rays, the direct overhead rays hitting the equator, they're actually hitting a line 23.5 degrees. That number sounds familiar. 23.5 degrees, that's the same amount of tilt of the Earth. So on June 21st, when the Earth is tilted towards the sun for the summer of the northern hemisphere, the most direct rays are going to be at 23.5 degrees above the equator. Remember, these are degrees of latitude. 0 degrees is at the equator, 90 degrees north, 90 degrees south, that's the South Pole, and the North Pole. So we're going to use a model of this to measure the intensity of the sunlight at the Tropic of Cancer, the most intense sunlight in the summer. That's about Mexico City. We're going to go up 15 degrees of latitude. That's about the US state of Denver. Then we'll go up to 53 degrees. That's getting to Canada in the Yukon Territory right over here in British Columbia. And then we'll go up to 68.5 degrees. That's getting right to where I'm from in the center of Alaska, or Fairbanks. All right, let's look at our device and how we're going to measure the intensity of light at those four locations. Demonstration, we're going to use a light sensor right here to detect the intensity of the light, or what's called illuminance. It's going to show up here, and this flashlight represents the what? That's right, the sun. So what we're going to do is we're going to make ourselves a chart. Get your chart ready right now. This is the angle of this ramp beside me, which represents these latitudes in the summer on the Earth. And you're going to record the luminance as it shows up. So, all right, let's turn our flashlight on and record our data. Our first angle is going to be 0, and we're going to zoom in on this and see that the luminosity is somewhere around 930, 940, somewhere in that range is fine. We'll zoom back out. We'll adjust this to 15 degrees. And we'll reset this light sensor so we can see our new value now has decreased to about 600. So we've gone up in latitude to about the US state of Colorado, and we see that the light has decreased in intensity. Next, we're going to come all the way up to 30 degrees. This represents just above the US and Canada border. All right, our luminosity decreases to about 400 once it settles into the right place. And then finally, we're going to bring this up to 45 degrees. This represents the intensity of the sunlight way up in Alaska in the middle of the summer. They get a lot of hours of sunlight, but much less intensity. So if we try to hold this in the right place, we can see the intensity decreases to about 200. All right, I hope we've recorded all of that data in your chart. Remember, these are the degrees on our ramp, and they represent these different latitudes across the globe, and that is around June 21st, when the Earth is tilted towards the sun for summer in the Northern Hemisphere.